Hello guys, I think are we good to go? Yeah. Steve, are you good on your end? Okay. Anyway, hi guys, we're back again for our next session. I hope all of you are in. Yeah. So basically, what we started last week was Chain Fusion series. I'll just give a brief overview of what we were just doing. Basically, we were looking at how ICP has been able to fuse or integrate with multiple blockchains that exist at the moment, such as Bitcoin, Ethereum, major layer twos, Solana, yeah, and then new upcoming ones. So we briefly explained what how chain fusion basically works, and we were talking mostly about keys. There has to be some signing keys, um, especially when you're talking about chain key cryptography. Yeah, and yeah, some kind of smart contracts. Checked out some type of keys such as ACDSA signing keys, what they are, and how Canista smart contracts can have their own ACDSA type of keys. Yeah. Um, this is basically just an image of how canister smart contracts using the SDSA keys get to communicate with different chains. Yeah. And then now we're talking about Bitcoin. We are starting with Bitcoin as our first for our series. And we checked out, of course, the birth of Bitcoin was done by a non-person or people called Satoshi Nakamoto in way back in 2008. And Bitcoin basically launched in 2009, where it was introduced as the first, I guess, decentralized cryptocurrency using blockchain technology. All these other currencies that currently exist, even the currencies that most of you did in your meme coin projects wouldn't be existing if it wasn't for Bitcoin. So Bitcoin plays a very, very major key role in the whole cryptocurrency ecosystem. Yeah. We saw how Bitcoin is integrated. Of course, using ChainKBTC, and then we defined what CKBTC is, which is basically ChainKey Bitcoin. It is a twin of Bitcoin on ICP. It is 100% backed with real Bitcoin, held in custody by a smart contract. When you check out the ICP transactional dashboard, you'll always see how much CKBTC has been stored at the moment and how much keeps on increasing. Yeah, this is how Bitcoin works. Using smart contracts that basically do validation calls for Bitcoin blocks. Yeah, and they basically extract transactions or UTXOs. Yeah. So basically, CKBTC has some features. First of all, CKBTC is an ICRC1, 2, or 3 type of token, but mostly it's defined as an ICRC1 token. We have various types of methods that you can use in tokens. You're gonna see some of them. This particular topic takes us back to our meme coin projects, when we were defining types of tokens that we have at the moment. Let's see. So we defined some before. Just give me a second. Sorry. Yeah. So back in our token classes, when we were doing meme coins, I guess 3 months back. Yeah. When we were doing our whole introduction session, we checked out different types of tokens that exist on internet computer. So there's basically an ICRC1, there's an ICRC2, there's an ICRC7, there's a DIP20, there's a DIP721, and then there's an EXT, extendable type of token on ICP. There are more other tokens coming in, but the major ones that probably peg ERC20 type of token is the ICRC1 type of token. Yeah, so ICRC1 is basically it's a fungible standard that provides a common interface for fungible tokens on internet computer. Yeah, it addresses the need for uniformity in fungible tokens interfaces, as various non-compatible interfaces had emerged alongside the ICP ledger. Yeah, so the ICRC1 token standard was created by, of course, community working group and is designed for fungible tokens such as CKBTC that we're looking at, CKETH, and SNS types of tokens, and even more. Yeah. So an ICRC1 token is really, really powerful and plays a very major key role, especially when you're talking to chain key Bitcoin. Yeah. So let me bounce you guys back here. So yeah. So basically that's what you should know about CKBTC so far. And basically CKBTC needs to have as you're seeing in this particular image, CKBTC has needs to have a minter where the minter is always holds Bitcoin. It's just like, think of it as an account that gets to create the actual tokens um in existence or hold them, yeah. And then ledger is basically where you manage your particular transactions. Let me go back to our token sessions here, where we were defining an ICSC1 type of ledger. Yeah? These are the various languages that we're gonna be using, mostly in these sessions, but mostly Motoko and Rust. Yeah. A ledger is basically it's just a type of think of it as a record keeping database holder. It basically holds the transactions and everything on that particular chain. Yeah. But the most simple term of what a ledger is, it's a type of record keeping where financial transactions are recorded. This concept has been around for centuries. A ledger database is somewhat more modern and commonly refers to a type of database that uses cryptographic techniques, including blockchain, to secure data and enable an immutable ledger. Yeah? Too technical, but just basically know a ledger is what is responsible of record keeping of transactions. Yeah. In internet computer, ICRC1 is like, let's say, the first non fungible token that is always, it's pegged like as the ERC20 token in Ethereum. Yeah. But ICRC1 also has its own type of ledger. So it has its ledger. Let me show you on the dashboard. Basically, what a ledger is, can always check. Let's see. Let me check these particular transactions. When you all these transactions that exist here on ICP, depending on which type of chain you're checking, all of them have to be supported by a ledger. So when you're talking integration, we usually have a ledger canister. Yeah. So as you can see here, the brief explanation is a ledger keeps tracks of accounts. The ledger canister maintains a set of accounts owned by principals. Each account is associated with a token balance. Account owners can initiate the transfer of tokens from the accounts they control to any other ledger account. All transfer operations are recorded on an append-only transaction ledger. Yeah. So an ICP ledger is hosted within, of course, NNS. And NNS is basically, our main, say, governance system for internet computer. I told you guys you should always join the staking in NNS and take part in it. You can always stake as low as one ICP for 8 years, and participate in the internet computer community. Yeah, but basically ICS or ICP ledger is hosted on NNS, and it records all balances of an ICP token itself in the manner similar to a spreadsheet. Yeah, each row is called an account, which has two fields. This is basically the dashboard I was showing you. You can always see differently. Also, you can check on ICP. Yeah. ICRC1 in full is actually Internet Computer Request for Comments. ERC20 is usually Ethereum Request for Comments. So as you can see, the only difference is the name. ICRC1 is basically Internet Computer Request for Comments. So it's a really powerful type of token at the moment. Even when when you guys are building your particular meme coins, most of you guys build an ICRC2 token or ICRC1 or ICRC3. Yeah. When we come to, of course, when you're talking about ICRC1 type of token, we usually have accounts. So accounts are basically responsible of transactions. Yeah. So we have a principal can have multiple accounts. Each account of a principal is identified by a 32-byte string called a sub-account. Therefore, an account corresponds to a pair principal and sub-account. Yeah. The account identified by the sub-account with all bytes set to 0, the default account of the principal. This might seem a bit too technical, but this is basically just a small protocol type of code that represents account and sub-account. These are what I wanted you guys to see. We have different methods that you use, that ICRC1 let's say functions for it to be a fungible token. Yeah, one of the methods is this one that you're seeing here, ICRC1 underscore name. We're gonna see that in our particular ICRC1 ledger canister, and yeah, we have ICRC1 symbol. This basically represents symbol, like for example, assume you're creating a token and you're calling it, wrap BTC, so the symbol name is WB whatever. Yeah, so of course you need an ICRC1 token needs to have a name, needs to have a symbol. Yeah. It needs to have decimals. This is now where you can get to define the transaction fees of your particular token. Some tokens, how they are actually created, if you're not always keen with the tokenomic structure, the gas fees might always end up being higher. Yeah. Of course, there's the fee method over here. The decimal method probably actually just explains more of how many are you using. Yeah, how many, 1 million, 1 billion, whichever number you have actually decided on your tokenomic structure. We have ICRC1 metadata. This basically returns the list of all metadata entries for this particular ledger. This is just different methods of how you call them. We have the total supply, which returns the number of tokens on all accounts, of course, except the minting account. Be very careful. The minting account is usually very important. Yeah. Of course, you have the method for minting account. For an ICRC1 token, we have ICRC1 balance of, which returns the balance of the account given as an argument. And then we have the ICRC1 supported standards. You can always use this, if you want your token to have at least extensions, because as you can see, we have ICRC1, we have 2, we have 3, we have, I think 49 is almost coming, even maybe it's here. Methods, of course, we have this that I was saying, and then this is a minting account is basically a unique account that can create new tokens, and it acts as a receiver of banned tokens. When you're talking minting, you have to consider banning, because if you're creating, you have to also consider deleting. Yeah. So the create, read, update, delete um, type of method is always considered in um, most functions. Yeah. So transfers from minting account act as mint transaction, depositing fresh tokens on the destination account. Mint transactions have no fee. Yeah. And then transfers to the minting account act as ban transactions, removing tokens from token supply. Ban transactions have no fee but might have minimal amount requirements. If the client tries to ban any amount that is too small, the ledger should reply with an error or so. Yeah. So now let's go to how to set up ICRC1 type of ledger. But then that's just a brief introduction of ICRC1, and I'll show you guys how it comes back to our particular topic of CKBTC. Yeah. So last week, we were basically following through this particular tutorial. For those of you who do not have it, let me post it on the chat, because we defined, I posted it on the chat. So last week we basically started this whole series of what is CKBTC. Yeah. And we just wanted to do a practical way and see a real world use case of how we can get to actually create a particular CKBTC into existence, and also just have a bit of interaction with CKBTC, right? So I sent this I think on groups for those who are following. If you are not, it's okay, because actually you found when we are actually moved. Yeah. So what you needed to do was just follow these steps. You can download a plug wallet or a Bitfinity wallet. Yes, and then yes, you can download a Bitfinity wallet, and then after you do that, you basically were supposed to run the next step, which was install Electrum over here, and I had mine installed. And then once you install Electrum, the next step was follow this, run this particular command. And then this command will basically open to you an account. And then of course, don't forget the password of the account. This is, now my account. This is a testnet Bitcoin account that you see. It has a balance of 0.18502 Bitcoins. Yeah. And after that step, we basically took some free Bitcoins from some faucets. Faucets are basically, let's just say they're more like minters. They mint tokens to your particular account. Yeah. So we got from this particular website free tokens. We also got from Yeah, we also got from CoinFaucet some bitcoins. So I won't add more because we did that process last week. Uh, yeah, but basically this is the whole process. Next step, everything has been detailed, screenshotted, and then now the next step was, you know, get to clone this particular internet computer. Um, yeah, let me open it. It was IC, if I'm not wrong. Yeah. So you're required to clone this particular repository. I hope you have it cloned on your end. And then now we reached here. We reached here. Let me just finish this process and then we go to our next particular steps. Yeah, so I have opened it. The next commands that I'm supposed to run is here, cd, I think cd raster, and then we are we are just checking into this particular directory folder that is called testnet. So cd bitcoin, cd kbtc. Yeah. And then I think it's supposed to go to testnet. Oh, yeah, yeah, cd testnet. Okay, so our particular um let's just say we're in that particular folder. It's basically a Rust folder that has a Bitcoin folder of everything you need to know about Bitcoin building. When once you download this internet computer repository, there's a Bitcoin folder over there under the Rust folder where you can see different you know how you can play out with Bitcoin. You can always go a mile far. So basically, what we are doing is we want to actually make make this particular command whereby you want to do a canister call on the mainnet where we are getting a BTC address first. Yeah. So we basically what we want to do is, you see these free bitcoins that we had over here on this particular account. This account, if I want to see it, I'll just come here to receive, create a request, and then I'll see my account. So this account right now is loaded here with this particular bitcoin. So this, I want to transfer some of these particular bitcoins in this particular account that I'm going to create over here. Sorry. I want to create an account over here that is going to receive that Bitcoin from that particular account to another account. So we are basically doing a canister call where we are creating a new account. Yeah. And basically this new account is gonna be our same minting account. So I'll do this particular command and I'll expect that I'll get a Bitcoin address. My identity, I hope I did not forget. If I did, then I'll have to create a new one. Oh, nice. Nice. I'm okay. So as you can see here, this TB1Q, all these numbers, this is a Bitcoin address that I just generated. How did I particularly do that? Um, I basically just did uh, did that by calling this particular command, the FX canister network internet computer, we're calling it on the mainnet, get a minter Bitcoin address. So like I told you guys, minting plays a major key role. So this particular command called create gives us an account that is a minter account. Yeah, as you know, just like I told you, there's always an account and a sub account. Yeah, so this is our particular address. It's the same as this particular address that we have over here, where that has this particular balance. This one, as you can see, it's even TB. This other one is TB, mostly to show that this is testnet Bitcoin. Yeah. Then the next step that we were going through was yes, created that. Next step is you're going to send this testnet Bitcoin to the deposited address provided by the particular minter that we got. So I'm gonna go and send. I'm gonna copy this particular, I'm gonna copy this particular address, this Bitcoin address, and then I'm gonna click copy, and then I'm gonna send it from here. And once I send it, I should call this particular command to actually give me the balance of now the Bitcoin that has been sent. Yeah, so let me first come here in my Electrum wallet that has testnet Bitcoin of around 0.18502. So I'm gonna pay to this particular address, the address that I have actually made a canister call, and it has given me a minter Bitcoin address. Yeah, and then let me just say we are doing chain fusion. Amount, I think I'll send the maximum amount, but of course I need the gas fee, so let me just send 0.15 of BTC. The rest I'm gonna get after. Yeah, and that I'm gonna click pay. 0.15. The problem with Bitcoin is it usually has yeah, let me see, 0.1. It usually has a huge gas fee. Sorry. Yeah, let me see if I can send 0.1. Not enough funds. You need to set a lower fee. Okay. Let me see if I can send 0.05. No. I hope it will be enough, but let me just confirm over here. This was yeah, so I guess the gas fees should actually work because this was 0.96 used. Let me see because I need 0.0. Let me see 0.09. I guess the gas fee, if I can get more Bitcoin over here. In the meantime, just a minute. Okay, let me get some free Bitcoin and see. Okay, let me see if we can get some free as I look at the gas fee. Okay, this one is okay. Let me verify. Okay, so yeah, at least we got some free from here, and let's wait for the other one. Sorry. Okay, as it's doing its thing. Yeah, it's coming in. Yeah, let me also still try to send here some of this then. Oh, okay, yeah, okay, it can. Let me see, 0.0. 0.0076. Okay. Oh, yeah. Okay, at least this one came. Well, let me add them to 80. I guess Bitcoin is a high gas fee type of bit of chain. Okay, so I think my password. So basically, what I'm doing, I have sent testnet bitcoins, part of it that was here in this Electrum wallet. I have sent it to this particular minting Bitcoin wallet that we auto-generated down here. So the next call that you're gonna be doing is we are gonna save your files. I told you guys you're following the tutorial so that you see that you can go step by step. Yeah, once you achieve this on your end, so that's why I'm really advising everyone do it. I know some people always come back and watch these particular videos. It's better if you actually do it on your own. Get those errors, say where you're stuck, and then yeah, it will go a long way for you, and always follow up with us in case of anything. So this is the next command that I want to run, and basically this command is the fx call minter update balance. Basically, what it means is we are actually, the first command was minter get BTC address. We got our minting address here. The second command now is telling us the balance. We want to see if this particular account that we requested for, we can give it some Bitcoin because we want to do the interactions over here. Yeah. So as you can see here, it tells you payment sent. You can always see on the history. The only problem about Bitcoin is now other challenges that now, that's why ICP comes in, that we want you guys to see is so far so good. I have sent some Bitcoin to myself. The gas fee, I just sent myself 0.0 08 Bitcoin, but the gas fee is as high as this 0.0148 Bitcoin. Another challenge that normal Bitcoin usually has is this particular Bitcoin that I have sent right now from my Electrum wallet has still not reached my destination. That means it still has not reached here on this particular Minter account. The reason being is because sometimes Bitcoin, and that's the challenge that I guess ICP also comes in to solve, is slow transaction fees. Sometimes Bitcoin can take you as much as 80 confirmations. When you're seeing here inputs, outputs, it takes long to do it. Let me see if we can track this particular transaction. Yeah, maybe there's a transaction ID over here. Let me see if I can track it real time. Let me see if we can get that canister ID. Okay, let me, I hope it gives me. Okay, I just can't find it, but yeah, we're gonna confirm if our particular amount has reached, because it still says, you see, our transaction is this one, Chain Fusion. It still says unconfirmed. That means the tokens have not yet reached. Yeah, so but I can track this by just copying the transaction ID on any platform that fetches. Let me see if Explorer helps. But that's not actually what I want us to do mostly. Let's just jump that step. of seeing the transaction. But basically, what you should know is when it shows here that it's still unconfirmed, then it means that it's gonna take a while. So like as you can see here, it has now given us one confirmation after how long ago did I send that particular Bitcoin. I sometimes have to wait as much as it to reach 80 confirmations to actually receive my Bitcoin. So um that's why using CKBTC, it's a game changer, because if we were actually sending CKBTC to this particular account that we have over here, it would actually take probably 1 to 2 seconds, and I have my particular CKBTC. So that's how Internet Computer comes in to scale Bitcoin. That's one of the major ways that has helped, and actually it's actually helping because all the particular transactions, they still happen on the Bitcoin network. If you're using CKBTC, nothing changes. You're not changing anything on the Bitcoin network. Everything is as it is. The only difference is now you're receiving your Bitcoin in a faster way, and the gas fees, like I was telling you, the gas fees here were high. The gas fees, if you're using CKBTC, is so cheap. Yeah, so this is a good way to scale Bitcoin. If you're actually saying that you want most people to move to Bitcoin, because Bitcoin is the first cryptocurrency on its own. But if you're thinking a world whereby all other cryptocurrencies have to, like Bitcoin is the one that, because how the tokenomics of Bitcoin has been set is it's only gonna be 21 um, million Bitcoins, and the value of Bitcoin keeps increasing. You guys can see the market how it is right now. I don't know how it is, but as you can see, the value of Bitcoin always keeps moving. I think today it was at 66K or something. So that means that this is an asset that probably um, the price will go up based on the halving, because the last halving we had was on April of 12th, I think. That was months ago. And usually after a halving, that means there's a shortage supply of Bitcoins existing, so that we have only 21 million Bitcoins. So sometimes the price goes up, but it usually takes time. Not always immediately, but it usually takes time. And when the price of Bitcoin always go up, then most of these other coins always flip one way or another. So Bitcoin always plays a major key role. That's why we need to actually make changes on the Bitcoin network to make it better for everyone. And one of the best ways is ICP integrating CKBTC. Now I hope you see the whole connection of how Chinky cryptography plays a really, really major key role in actually integrating ICP. Yeah? So as I'm just waiting for the amount to reach in my particular wallet. Maybe it might take a few minutes. Then I think it will. We're just gonna call that command. But basically, what you're seeing here is now chain key CDSA signatures. So these whole transactions, this is how now chain key CDSA signatures come in on ICP, whereby, like I said, each Canister smart contract holds a key, and these keys now can be able to communicate to the Bitcoin network. So canisters can receive, hold, and transfer Bitcoin in a secure manner. This is the whole transactional flow of how it works. Now, how CKBTC works on Bitcoin. So there's the chain key transaction over here, yeah, and there's always a canister code over here. So there's always signatures of ECDSA. That like I told you, have keys that make the signatures, and then there are two canisters. Think of it as two canisters. Maybe one can be a Bitcoin canister, the other one maybe can be a ledger, So there's always some command like the one we have done, get balance, get UTXOs, and this is how they actually get to communicate between each other. So Bitcoin, the way it exists, does not have smart contracts. But if you're bringing in chunky cryptography to actually work on Bitcoin, then we give it a canister. There's actually a Bitcoin canister that gets to exist. So that means everything on Bitcoin is communicated through that particular canister. Yeah. This is just a payment flow that we did about SRC1. So as I was explaining that, I think we are good to go now. Yeah. I can see here. Let me check. The transaction looks okay. It still shows I don't know how many confirmations. Oh, it's still one confirmation. So let me see. Let me run this particular command and see if my Bitcoin actually reached. If it gives me an error, then it means it didn't reach, and yeah, we'll have to wait. So of course, I'll put another thing that maybe you should note is if you're doing this particular tutorial, you need to be doing it in create an identity on your particular terminal. How to create an identity is easy. Okay, so let me see if my particular command has come. The confirmations are 3 so far, at least they've increased. So probably the Bitcoin is coming in. Let me confirm. Yes, so yeah, so they should be good now. As I can see, it shows. So yeah, our Bitcoin has actually reached, but it took a while though. But it's still coming in completely. Like this particular minting account has already made that call and is actually executing that particular transaction. As you can see, it looks like a clock. Means it's the time. Once it gives this tick, then that means the actual Bitcoin has reached completely successfully. But at the moment, we can still see it in our particular minting account, this one that we generated up here. Yeah. Guys, I can see my time is almost up. And the way this is huge. Chain Fusion series is very, very huge. For those of you who maybe will go further, we have the Chain Fusion hackathon that's ongoing at the moment. Anyone who wants to come in and take part in it, see how people are building on Bitcoin or Ethereum. I'll just post for you a particular link, and then yeah, you can actually just join in. But yeah, we're still on our Chain Fusion series. We're not far. We're just now going more deeper into Bitcoin and how Bitcoin actually really works. Because once you understand how Bitcoin works, then it's easy for you to actually make a particular dApp that uses Bit. Yeah, and actually when you do that, you get to boost the Bitcoin ecosystem. Sorry, I think my laptop. If it hanged, okay, it's good now. Let me close this. I was just showing you guys about Chain Fusion. I talked about Niger. Yes. So I think we can continue to our next step. Sorry, we're back here. Yeah, so I think now Bitcoin, let me call the same command and see. Yeah, so I was saying that before you even run this particular commands, these two call commands that I'm doing over here, you need to actually create an identity. An identity is more like now your particular ICP, let's just say wallet balance or something, somewhere where you can hold your particular cycles and yeah, just think of it as more like a wallet. So that's why when I'm running this particular command, it's just asking me please enter the paraphrase of your identity. So if you don't know how do you actually create an identity, identity, I can just check run dfx identity list, and I'm gonna see the particular identities that I'm using. For those who are following last week, I actually created my Chain Fusion identity. That's the one I'm using it. If I want to use a different one, I'll just do dfx use the name of that identity, but at the moment I'm okay. You can see that I'm using this particular identity, Chain Fusion. That's why after every command call I am getting, and please input your particular description. Yeah, so at least I have tried to go small and small. Yeah, so what you're gonna do now is you're gonna hope this one is, let me just take like 5 minutes of the time, guys, and then yeah, because now after this we have to go to our next session. Yeah, up to next week. So now we want to transfer this particular CKBTC to maybe another wallet. So this particular CKBTC that has been sent over here, we want to actually just transfer it now to a different wallet balance. It can be a Bitfinity wallet balance, or you can use Bitfinity wallet because Bitfinity really supports CKBTC, or you can also use or you can also use Plug wallet. Whichever is okay, but I just preferred using both of them so that if one works for you, maybe the other will work for you. So what we are doing is now we are just want to send it to now another CKBTC wallet. But in this sense, we want to send it to this particular Bitfinity wallet. If I'm logging into Bitfinity, I have to log in to my account with my internet identity, which is a cool feature you can always consider when you're setting up your particular wallet. So the whole point of these sessions actually is to also make you guys think outside the box. Like you can always build anything. You can build a wallet, you can build anything. Once if you're talking about, yeah. So yeah, I have set up. Good. Yeah, so I'm gonna send myself some CK test BTC from this account to this particular account over here. I think this is my Yeah, when I can select it, I can see deposits, BTC, that's real Bitcoin. Yeah, but I can see here I can receive tokens. I can receive CKBTC or RCRC1, which we actually, like I told you, Bitcoin is an ICRC1 token, so you can receive them using your particular principal ID over here. So let me see the next command. Uh, 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 um, so I'm gonna copy this, and then so there are two ways I can actually get a principal. Yeah, I can actually get to call this adapt command to get a new principal account if I want. Yeah, but also I can get it through if you're using plug is also just like the same one I have at the moment. I have disabled plug just temporarily because I use it in my other Brave browser. It still has a principal ID account. Yeah, so I can get to copy this and then I can copy it, and then I can add I get to add this. I get to send it over here. Yeah, so let's just basically do it practically. Yeah, so my account over here has my CKBTC account over here basically has 0.003 whatever CKBTC. So what I'll do, I'll just copy first my principal ID. Now I'll first actually run this particular command that basically transfers the CKBTC. So first of all, before you run this command, make sure that the Bitcoin that you have actually sent has reached the other side. So I'm also a bit keen on this. So when you follow this tutorial, I have actually done it. There are two ways. You can actually send it to a particular principal ID address that you've gotten. Like for example, as we've taken this one for Bitfinity Wallet, for it to make it easier, or you can actually get to create a new one by running this command, dfx identity get principal. It will give you a new principal ID, which is more like an address. You can go to Plug Wallet and actually put that canister ID, select it as an ICRC1 token standard, and you'll actually get to see your Chainky testnet Bitcoin on Plug Wallet. But of course, the other way that now we are using is we'll actually just send it to our Bitcoin wallet because of time, and then yeah. So I have run this command, and when I run this command, it tells me that I need to replace this principal. I need to replace this principal ID for that particular command. Send J, yeah. So let's see if we can add. Let me confirm that I have pasted it. I just need my principal ID. My principal ID over here now is this one, SB5AS. let me replace it. Sorry, let me replace it in this particular situation, because basically what this command means, yeah, so I have put it over here. I hope it will come up. Basically this command, what it means is we are calling an IC, Internet Computer Ledger, ICRC1 ledger, to actually transfer some of this particular Bitcoin to now our destination over here, to this principal ID address, so that we see if our CKBTC increases. Yeah, so you're the one who is supposed to select the amount over here. Amount, you can put it as, say, 5. And then yeah, so principal ID, and then just replace that particular amount. I hope it goes through, or maybe if it doesn't, then oh, I put my password error, sorry. Oh, yeah, so most likely it's because this particular Bitcoin has not yet reached, and that's why guys we're saying that one of the challenges of Bitcoin is yeah, it takes long, so we'll have to wait. And because now imagine, for all that time we've had like probably 3 confirmations, so I can't make that call. What I was actually doing was I was sending my Bitcoin from this particular address that we created over here to go to our Bitfinity wallet, CKBTC, just not principal address, but yeah, we'll have to wait. So yeah, I think basically that's it. Please do this particular tutorial and follow up. Next week when we come back, we're gonna go to now the deeper sense of CKBTC. I felt it was right to do the tutorial that we did, so that you just confirm on your end that you're okay. But yeah, we're gonna do another CKBTC example, but this one is gonna involve more coding. We're gonna be using Motoko next week, and like I showed you, I'll send you guys this tutorial. Just set up an ICRC1 ledger locally, and then yeah, be set for next week's session. Kindly, yeah, as you can see, next week's session is now going deeper into what we've been talking about, the ICRC1, this Bitcoin canister, and the likes. Yeah, so we're still on CKBTC. Thank you guys for attending this, and I'll stop this. Yeah, and yeah, feel free to reach out in case of any issue. Yeah, so over to you, Steve, if you're here.
Yeah. Okay, so we'll share the recording by tomorrow. And also the resources. I think Tevin has sent some of them. Yeah, and yeah, just you can go through the recording so that you can get like some prerequisites for the next session, which will be next week. Yeah, I am assuming there are no questions. Okay, nice. Yeah, so we can end the call over there. Thank you, guys.